Okay, folks, you saw lesson 1-2. Now let's go over section 1-3. Hopefully you didn't have too much trouble with 1-2. It is a little tricky because it's all intro. Now we get more into specifics with the chapter. I will tell you this right now. Chapter 1 is probably one of the more difficult just because it's intro, and then chapter 2 is another difficult one. After that, it gets more smooth, and we'll talk more about that in coming weeks. We'll see how things go. So once again, I'm Mr. Burrington, and you're in my geometry class. So let's get started. All right. Section 1-3 is on measuring segments. Now we talked last time about a segment being two endpoints with all the points in between. Or basically, if you take a line and cut it off at two spots, everything in between that. Now, just like with the segment, or just like with the line, a segment has infinite points. All right. Now, this homework quiz, I'm going to send it out as a Google form. And it's basically, what do I want to get out of this class, and what do I need to do to get the most out of this class? Normally, I'd have you fill out a piece of paper, and I'd read them. I'm going to send it out as a Google form. I'll post it on Canvas in the next, and it may already be there by the time you watch this. And I will read each one. Don't worry about my feelings. I'm just be honest with it. Okay. All right. Now, today you'll be able to determine the relationship between each of the given measures given the information. So if two segments are the same length, we say that they are congruent. Two segments, same length, they are congruent. Congruent is a big word in geometry. We're going to be using that all throughout this class. I don't know if you heard it in algebra or not, but you're definitely going to be hearing a lot here in geometry. But congruent means when two objects are of the same shape and size. Now, with the segment, it has no shape. It's just basically length. So as long as they're at the same length, they're congruent. And the symbol for congruent is right there. It's an equal sign with a little squiggly line above it. That's congruent. All right. So here's the thing, though. Segments, the shapes are congruent, but their distances are equal. That's because the shapes are what's congruent. So I'm going to write this over here. Shapes are congruent, but lengths are equal. All right. So like right here, you're given that segment AB has a length of 7. This basically says the distance from point A to point B is 7. And the distance from point C to point D is also 7. So since they both have the same length, they both have a length of 7, we say that they are congruent. So segment AB is congruent to segment CD because they are equal in length. Make a note of that. So shapes are congruent, and lengths are equal. I feel like a weatherman because they're always using those in the. Anyway. All right, I'm just kind of rambling on right now, so let's go ahead and go on to the next page. All right. If points A, B, and C are collinear, that means if you recall from lesson 1-1, that means they lie in the same line, and B is between A and C, then that means the following. All right. That's an example of the segment addition postulate. I'll talk more about that in the semester. This is just kind of get you into that. But it says the distance from A to B, this segment, plus the segment distance from B to C equals the length of the whole segment. So basically, this part plus this part equals the whole thing. So in other words, if I say that AB, which I'm going to say which I'm told is 17, I'll write it down here. B, we don't know. We're going to call that X. Anytime you have an unknown, you can assign it any variable you want. Let me say that again. Anytime you have an unknown, you can assign it any variable you want. I'm going to call it x. And then AC has a length of 31. And I just plug in all the information. I'm looking for BX. We called it BC. We called it X, and we just subtract. So X equals 31 minus 17, which you know X equals 14. So X is 14. All right. So there, all you do is plug in the information and then solve for the missing component. In this case, it is segment BC. All right. Now, if I do this again, I'll do this right here. I'm going to plug in this information. This time, I'm given, and I'm going to write the whole thing. I'm going to write the whole equation down. AB plus BC equals AC. I'm writing it down again so that I have a visual of it. It's imperative that you do that too. Just get some practice, especially if you're doing this on your own. All right, now AB we know is 11. BC has a length of 3x minus 5. And AC has a length of 48. The big thing is you just have to plug in the information. All right, got to do some algebra here. Yes, you're doing some algebra. So let's combine the like terms. 3x, and then I have 11 minus 5. Well, 11 minus 5 is just simply 6. So now I have 3x plus 6 equals 48. So from there, I subtract the 6, and I get 3x equals 48. And I want to write this out, minus 6. So 3x equals 42. I rewrote it. So 3x equals 42. Ooh. I don't want that. That's why I clicked it off, because I don't want it. I don't know what it was. I still don't want it. All right, so 3x equals 42. Then you divide, and you get x equals 14. All right, now here's the next thing. It also wants to link to BC. So now that I know x, I can plug that x value into BC and get BC. So BC equals 3 times 14 minus 5. You have to look what's asking for. If it's asking for the value of x, you're done. But if it asks for something else after that, you have to plug in that value of x and use that to help you get what you're missing. In this case, it's BC. So 3 times 14 is 42, minus 5 is 37. So 3 times 14 minus 5 is 47. Okay, so we have that. I'm saving it so I don't forget it. All right. Now you can go back and look at it later if you like. Okay. Now, little review of a couple things I need to talk about. Distance between 2 points on a number line. Okay. So it's a lot easier than what it looks. I'll tell you that right now. All right. The distance between point A, which is at 3 on the number line, and B, which is at 31, is just simply 31 minus 3, the absolute value of that. Well, the absolute value, that's going to be 28, but the absolute value of 28 is just simply 28. So it's 31 minus 3, absolute value of that, which is the absolute value of 28. And then you subtract, then you take the absolute value of 28, which is just simply 28. All right, now you remember that stuff. You should remember absolute values from algebra. Remember, absolute value is the distance between any 2 points, and distance is always positive. So remember, distance is always positive. Even for AB, for this one. For this one, we have 7 minus negative 41, which equals 7 plus 41, which is just simply 48. For those of you NASCAR fans, that's Jimmy Johnson's number. If you're not a NASCAR fan, you'll learn. You'll learn someday. If you're around me long enough, I talk about it a lot. I talk about some other things as well, but you'll get to know that. But anyway, it's 48. All right. By the way, disclaimer: you don't have to be a NASCAR fan. I am, so that's all that matters. All right. Let's go back to. I'm going to do this one real quick. It's a review from algebra. I'm just going to do one of the two. Distance formula you did learn in algebra last year is the square root of x2, which is 6 minus 3 squared plus 8 minus 5 squared. We'll talk more about this type of distance formula in the coming days or in the coming weeks, but I will at least go over real quick while I have your attention. All right. Then square root of, that's going to be 3 squared plus 3 squared, which is going to be 9 plus 9, which is the square root of 18. Now, there is a way to break that down, but we're not going to do that right now just because of time. I need to end this video, and we'll cover part 2 here in just a moment. Actually, I'll probably cover that in part 2. So